Okay, how we doing? This will be our first flipped classroom presentation here, and we're going to start with section 8.1, which is exponential growth. This starts a new family of functions for us. We're just coming off the square root functions and the cube root functions. So this is the next one in our progression. So 8.1, exponential growth. Exponential growth has the form y equals a times b to the x. So now our variable is up in the exponent, and that's what makes this an exponential function, exponential growth. Some notes here, a has to be greater than 0. So it has to be a positive number. We're not going to deal with negative numbers. And b has to be greater than 1 for this to be growth. Remember, we're going to raise this number to some other number, and for this to become bigger, to get the growth, it has to be bigger than 1. Here is a sample of a graph of an exponential growth function. So here's the function here. It's very simple. Y equals 2 to the x. So if you take it back to our previous one, we have a times b to the x. Our a is actually 1, so it doesn't really show up here. Our b is 2, and it's being raised to the x. So here's a little table of values here. When I input the x values of -2, -1 through 2, you put into your function and you get these values, and when you plot them, you get these blue points here. Drawing a line through those points gives you the shape of the exponential growth function. You'll notice that if you were to keep going in the negative direction here, so -3, -4, and keep going to the smaller numbers, the line will never ever actually get to 0. Because even if you put a huge negative number in here, it'll put the value in the denominator, but it'll never be 0. It'll always be some tiny amount. It'll never go negative. So this line we call an asymptote. It's a line that the graph approaches as you move away from the origin, but it's never going to cross it and never going to reach it. Never going to touch this line that's y equals 0 right here. So it's going to get very close, but never touch it. Imagine yourself walking towards a wall, and someone said, okay, walk half the distance, then walk half the distance, and you keep walking halfway to the wall. Even though you get extremely close, you'll never actually touch the wall. Here's another example. Now a is a half and b is 3, so it's going to change it a little bit, but it'll still have the same general shape to it. So we're going to plot 2 points this time. Now, instead of the 5 points we did last time, we're going to be a little bit smarter about it and just plot 0. So we put 0 in for x. Remember, anything to the 0 is 1, so that just becomes 1, and you get 1/2 for your y value. You put in 1, 3 to the 1 is 3, times a half, you get 3 halves. There's those 2 points plotted. That's enough to give you a graph. So you know you're going to have this flat line, this asymptote, go through your 2 points, and then you want to turn it up. It's pretty similar to how we graphed square root functions. Okay, then step 2, from left to right, draw a curve that begins just above the x-axis.
Miss Murphy, please call 46113. Miss Murphy, 46113.
For this one is y equals 0. These 2 examples are simple versions. Here's another one, a little shorter this time. So now at this time our a is -1, so it shows up just as a negative sign there, and our b is 3 halves. Put in 0, you get -1. Put in 1, you get -3 halves. And now, when we plot those 2 points, if we draw along that y equals 0 line and go through our points, now it's going to give us a down to the right shape. That's due to the negative sign. Okay, again, just like the square root functions and the cube root functions, it's going to be reflected in the x-axis. And there it is. It's going down to the right now. And again, our asymptote is at y